Hi, I'm going to be presenting on nuclear technology in the United States. In the beginning, the first commercial nuclear power plant opened for operation in 1957. It opened in the Simi Valley. Simi Valley, in California. It was called the Sodium Reactor Experiment, and LA was the first area to be powered by nuclear technology, nuclear energy. The absolute levels of technology, so I chose the same power plant that was first used in American soil, and it produced 7.5 megawatts per hour. This might not have been a lot, but at the time it was big, and it was a big step for nuclear power and nuclear power generation. It was the first power plant to power an entire city grid, and the city that it powered was Moon Park. That's about 10 minutes away from Simi Valley. It had a population of 3,000 at the time. Very small, but did the trick. It used uranium. That was the fuel that the power plant used. That's what was being. That's what created all the energy, and then sodium was the coolant. One thing that could have possibly reduced the amount of production that could have been done in this power plant was the lack of experience. The lack of experience of the workers. They didn't have much training. They didn't really know what they were doing a ton, so they didn't have the right knowledge or equipment to fully produce the maximum amount of energy that the power plant possibly could have produced. So the total power, the graph here shows the start in 1957 to 2017. And so in 2017, 20% of the power in America is nuclear generated. In the USA, only half of that is actually used. And that's also a stat from 2017. And from 1967 to 2017, there was a 800% increase in the generation of nuclear power and a 500% increase in the usage of that nuclear power. So the trends, the U.S. was a pioneer for nuclear power. They mainly used PWRs and BWR reactors, pressure water reactors and boiling water reactors. They're all mostly run the same way. The only major change were improvements to the safety mechanisms and the operating systems after the 3 Mile Island incident. This was where radioactive coolant leaked into the air, and this created a big problem. And so to fix that and to counter it so it wouldn't happen in the future, they inspected all the safety mechanisms and they looked closely at the operating systems and made sure they're up to date, and they improved them in many ways so they could not have a problem in the future again. So the public perception of all this before 3 Mile Island, it was the public approval of nuclear power was around 60%. After the 3 Mile Island incident, it dropped down to 40%. But then now in 2018, there was a poll that was done that said that 65% of the public approve of nuclear power in America. Most commercial reactors are privately owned. However, the government does have some say in the developments of these nuclear power plants. So the competition of nuclear power. So like I said, nuclear power produces 20% of the electricity in America, and the forms that it's competing with, or the other types of electricity that it is competing with, are hydroelectricity, which comes from water, natural gas, coal, and other extreme cases. Hydro is producing 8%, while coal and natural gas are the biggest competitors with nuclear electricity, as natural gas is 32% of all electricity in America and coal is 30%. So the projections for the future of nuclear technology. So a projection that really looked to have a lot of detail behind it and a lot of data behind it said that there was going to be a decline of 20.2 gigawatts in total production of nuclear power from 2017 until 2050. So the reasons were that because of oil and natural gas availability, the cost of actually generating nuclear power, and future carbon policies. The projections here of all renewable, a projection is that renewable electricity will increase in the future as nuclear power will most likely decrease. So to explain these graphs real quickly, this one says references. The TV cut it off a little bit, but this one is a references graph. This is if everything today were to stay the exact same from now until 2050, what everything would look like. This one over here is carbon fees. That is, they are trying to limit the amount of carbon emissions in the atmosphere and in the world. And so because of that, as you can see here, we have a fair amount of coal usage, and as time goes on, it very quickly dissipates. And this one is HRT. That means that there's a high availability of oil and natural gas. It also means that at some point there's technology advancements, and this shows that a lot of the natural gas here in the blue will, because of this, increase a lot and slowly start to push the other ones out of the way and almost take over. And LRT is the opposite. There's a low availability of oil and natural gases, and in this one, as you can see, it's as we are now, and then it quickly drops off and stays where it is. The best case scenario for nuclear power would be if carbon fees were to be implied, because there goes 1/4 or one sector of all electricity production in America. So people would have to step up to be able to satisfy all the needs of the people in this country. So nuclear waste. In America, there's 90,000 metric tons of nuclear waste. And most of the time, they are stored on the 121 nuclear power plant sites on American soil. And that is because they don't want to risk transportation because of past events like in the Yucca Mountain incidents. There were 2 of them that I saw that were most known and had the most detail behind them. The first one was a transportation problem. This caused an explosion because an insulator of the nuclear waste was actually cat litter, and there was a confusion and they put the wrong cat litter in one of the things, and the chemical in the cat litter reacted with some of the nuclear waste, and it caused an explosion which practically imploded the entire storage facility. And the other one was a rainfall. There was a heavy rainfall in the area, and water leaked through cracks, got down into the storage areas, and it started to react with metallic sodium. And this created a reaction which caused a lot of the nuclear waste, all the nuclear waste in storage, to also explode, along with all the other reactions that were happening due to the water and the sodium.